Very good morning, students. Let's begin with the topic. Let's recapitulate what we have studied in our previous classes. In our previous class, we have just completed our shapes of atomic orbitals, in which we have studied about s orbital, p orbital, d and f orbital. Okay. Rather than that, we have studied the quantum numbers, which are quite important topic for you, because on the basis of quantum numbers, we are going to pursue how can we put our electron, how can we fill up our electron in atomic orbital. Okay, so let's begin with our today's topic, that is known as energies of atomic orbitals. Quite important topic, first of all, and the most important point is the energies of atomic orbitals. We have studied that there are so many different atomic orbitals like 1s, 2s, 3s, 2p, 3p, and so on. So the point arises, how can we put them, how can we arrange them in the order of increasing energy? Why? Because the benefit for it would be, there would be ease for us for filling up the electrons. Okay, because on the basis of that, we would start, how can we fill up our electron? That is electronic configuration. Super important topic, super, we can say, for your exam point of view, as well as for your whole chemistry. Whenever you will read your chemistry, whenever up to BSc, up to MSc, or up to 12th only, whenever we will have to study the chemistry, the electronic configuration is the best thing. I should say it is like a stethoscope, just as for doctors, same as it is for a chemist, it is the main tool. Okay, so on the basis of energies of atomic orbitals, we would start how can we fill up our electrons. So before beginning that, the energies of atomic orbitals are based on 4 to 5 different rules. Okay, each rule suggests us some value, and the basis of these values we are going to write down the energies of atomic orbit. So the first one is, when we haven't much knowledge, we have just said only on the basis of n. What is n? The principal quantum number. Only on the basis of n, that is our principal quantum number, the energy increase. So on the basis of n, that means if I'm talking about 1s, the n equals to 1, same as it is for 2s. For 2, n equals to 2. For 3s, 3p, and 3d, n equals to 3. So this was the first rule which we have in our knowledge, that how can we fill up our atomic orbitals on the basis of energy. But the reason behind this is, since these two orbitals like 2s and 2p, they have been put on the same energy level, same as it is if I'm talking about 3s, 3p, and 3d, they have also been put in the same energy level. These are known as degenerate atomic orbitals. Okay, so how would I define degeneracy? The degeneracy is a property of atomic orbital, which on the basis of which we can define that those particular atomic orbital which have the same energies. Okay, so there is not only one orbital, there are more than one atomic orbitals, like 2s, 2p, like 3s, 3p, 3d. Same as it is if I'm going to 4 quantum number, 4s, 4p, 4d, as well as 4f. Okay, so these all are known as degenerate atomic orbital. That is the same energy, but different atomic orbital. Okay, ji. So this was the second rule, I can say, or second law on the basis of which we can put our energies. Same as it is, as we kept on moving, our third point suggests us about the ground state as well as the excited state. You know very well about the ground state as well as the excited state. Suppose our 1s is known as ground state. What is ground state? At which our electrons are in the rest position. Okay, this is something we can say that our electrons have been put on the lower level. But if we irradiate them with a particular energy, if we give them a particular energy, they would easily jump to the higher level known as excited state. And now, this all we have studied already, the ground state, the excited state, this all we have understood. So this was the point that our electrons can easily jump from one level to another level to another level by the absorption of some energy, which is known as ground state as well as the excited state. Okay. Now, this was the whole concept. But as we have studied about our nucleus, about our electrons, about our atomic orbitals, we have come to know about a new property that is known as shielding property. Okay, now what is shielding property or screening effect? Let's see, that is super important. Let's focus what is known by the shielding effect or the screening effect. Should I rub this? Okay, now what is our shielding effect or our screening effect and how can we define it? Let's start. Or screening effect. Now, what actually a shielding or screening effect can be defined to us? See, basically what's happening, we know very well that our atom are made up of multi-electrons. यानी ऐसा नहीं है कि our atom, it contains only one nucleus and only one electron that is revolving in our first state. Okay, this is not even possible. We have so many different electrons which are keep revolving in different atomic orbitals. Okay, now the point arises, this nucleus and this electron both are oppositely charged. You know that very well. Nucleus is are positively charged and electron is negative charged. So what's happening actually over here? The nucleus as well as the electron, they are attracting each other. Why? Because the opposite charge attract each other. You know that same as it is this electron and this electron, since these both are negatively charged, that means the charge is same and same charge would repel each other. So there would be an inter-electronic repulsion. What would I say? There is a kind of inter-electronic repulsion. Inter means within. And you know about the electron and the repulsion. So this is known as inter-electronic repulsion. Now what's happening about the inter-electronic repulsion? What's actually going on there? See, whenever we have studied about our inter-electronic repulsion or there is a strong attraction between the nucleus and the electron, what's happening? Whenever this nucleus is start attracting this electron, the another electron which are in the higher level or in the next atomic orbital, there is a kind of screening effect. There is a kind of shielding effect. That means ये जो न्यूक्लियस है ये इस इलेक्ट्रॉन पे जितनी एनर्जी अप्लाई कर रहा है इतनी ही एनर्जी के साथ ये इस इलेक्ट्रॉन को अट्रैक्ट नहीं कर पाएगा. सेम एज इट इज अगर मैं हायर एटॉमिक ऑर्बिटल की बात करूं तो ये इस इलेक्ट्रॉन को भी अपनी तरफ अट्रैक्ट नहीं कर पाएगा. द रीजन इज वी हैव different electrons between them. It is like our sun is over there and other planets are moving. So what's happening? Whenever I'm talking about the Mercury is the hottest planet. Why? Because it is nearest to the sun. Same as it is, this electron is having or is bearing the maximum attraction due to this nucleus. But these electrons, due to these electrons which are in the inside atomic orbital, they would have some screening effect. यानी उनके ऊपर जो actual attractive force होना चाहिए था, that is not actually happening due to these electrons. तो ये जो इलेक्ट्रॉन है वो उस चार्ज को, उस अट्रैक्शन को शील्ड कर रहे हैं. यानी they are behaving like a screen, they are behaving like a shield, जो रोक रही है, which is like stopping or which is like absorbing the extra energy which these electrons must feel. Okay, so this is known as shielding effect or the screening effect. बन रही है जी बात? So this is the most important topic known as screening effect. I hope you have got that. And this screening effect is denoted by Z effective. This is known as Z effective, that is effective nuclear charge. यानी जितना न्यूक्लियर चार्ज इस इलेक्ट्रॉन को फील होना चाहिए था वो उतना ना फील हो करके इन इलेक्ट्रॉन ने जो शील्ड किया है उसके बाद जितना चार्ज उसके पास पहुंचा है, दैट इज नोन एज इफेक्टिव न्यूक्लियर चार्ज. दैट मीन्स जो एक्चुअल न्यूक्लियर चार्ज ये फील कर रहा है, दैट इज नोन एज जेड इफेक्टिव. ओके. Now the point is, how can we say about this Z effective? यानी हमारे जो Z effective है, does this depend upon some properties? Quite obviously, this Z effective is directly proportional to charge upon size. Charge upon size. That means, if I'm talking about the charge, मान लीजिए your nucleus has the maximum positive charge. So what is the benefit? जितना ज्यादा मैक्सिमम पॉजिटिव चार्ज होगा उतने ही इलेक्ट्रॉन जेड इफेक्टिव को फील कर पाएंगे. बट ऑन द वेरी सेम बेसिस, इफ साइज इज बिगर, व्हाट इज हैपनिंग? साइज इज बिगर, द एटॉमिक ऑर्बिटल वुड बी एट द सेपरेट डिस्टेंस, एट द फार अवे डिस्टेंस. साइज बड़ा होगा, डिस्टेंस ज्यादा होगी, तो जेड इफेक्टिव जितना फील करना चाहिए था उतना फील ना होकर के कम फील हो रहा है. So in short, we can say it is inversely proportional to size, but it is directly proportional to the charge. That is the best point about the Z effective or about the nuclear charge. Okay, बन रही है बात? So this is all about the shielding effect as well as the nuclear charge, the effective nuclear charge. Okay. Now let's move to our next topic. We have seen that Z effective is directly proportional to charge upon size, but on the very same basis, it is also inversely proportional to our orbital quantum number L. So we can say Z effective is inversely proportional to L. इसका मतलब क्या है? So इसका मतलब ये है बच्चे कि if I'm talking about S orbital, P orbital, D orbital, जो S orbital है that is close to the nucleus, so that is tightly bound to the nucleus. So our S atomic orbital electrons are feeling the maximum Z effective. Okay, so S orbital have Z effective greater than P, then D, and then F. This is all due to this concept that our Z effective is inversely proportional to L. Okay, बन रही है बात? So what I'm talking about, I'm just saying that our S atomic orbital, since they are closest to the nucleus and due to inversely proportional to our L, they are most tightly bound to the nucleus. They are closely packed. They are closely feeling the maximum Z effective of the nucleus. Same as it is, the P would be feel the less. They are loosely bound, and F they have the far away. They would feel the maximum, the minimum Z effect. Okay, so this was the whole concept which is based on our Z effective, or we can say shielding effect. Okay, बन रही है बात? Now this was the whole concept in which we have studied about our different concepts. That is what's actually we can say the different points. We have seen 4 to 5 points. Each point have told us different values. The first one about the energies, and energies is directly proportional to N. The first point. Second, the degenerate atomic orbital. Third point, what is the shielding effect? And what is it is known as Z effective. Z effective is directly proportional to charge upon size. Fourth point, it is inversely proportional to L. So we can say S, P, D, and F, the far away the electrons are, they would feel the less Z effective. Okay, so this was the whole concept we have studied. Now, on the basis of these screening effect and the shielding effect, we have one more observation. And that is the important observation on the basis of which this concept would be completely changed. Okay, so let's start. What I have told you. Okay, I'm just going to cover this particular topic. See, I have told you that there is screening effect, there is shielding effect, और उसकी वजह से ऐसा हो रहा है वैसा हो रहा है, ये हमारा जो SPDF है, they are feeling the less repulsion and so much. Okay, so now on the basis of these concepts which we have studied after studying of the Z effective, हमारा जो concept था, that means कि energy जो है वो सिर्फ और सिर्फ directly proportional है to the N. That has been completely changed, and we have said that not only N, L also, I'm sorry for that. We are saying that not only N, but L also generates some effect on energy. क्या बोल रही हूँ मैं? I'm saying not only N, but also the L is dependent on the energies of atomic orbital. That is quite complex, but we have made it very easy. We have said that lower the value of N plus L, lower is the energy. दोबारा सुनो. The N plus L value, how much it is lower, that much is the energy of atomic orbital. Okay, and if the N plus L for two atomic orbital is same, then we have a special case that lower the N, lower the energy. And this case is only happening when N plus L value would be same for two atomic orbitals. So just keep that in your mind. Okay, now we have all studied this. So हमारा ये जो diagram था, that has been completely changed, that has been totally changed due to the effect of this N plus L value. Okay, so now we can say what I want to say to you, that now you can easily differentiate 1s, that is our ground state. If I'm talking about 2s and 2p, 2s के अंदर n कितना है? 2. L equals to 0. That means n plus L equals to 2. But if I'm talking about 2p, n equals to 2, L equals to 1, n plus L equals to 3. So our value is changed because we know very well L equals to 0, 1, 2, 3, SPDF. है ना जी? So after 1s, there is 2s. And 2p is somewhere higher in the energy than 2s. Okay, same as it is, we would going to jump to our higher point, that is 3s. Then 3p, somewhere upper. Then suppose 4s, 3d, somewhere upper else. Now you must have a query, bache, that ma'am, why is 4s and 3d are so much, the 4s is representing n plus L equals to 4 only because s equals to 0. But if I'm talking about 3d, it is equals to 3 plus d represent 2 equals to 5. So it is in higher energy. So our concept has been totally changed. 4s have the maximum quantum number, but due to n plus higher energy than 4s. This is the last concept on the basis of which we have put our atomic orbitals. Okay, so this is how we can put energies of our atomic orbitals. This is very important topic because on the basis of this, we will start how can we put our electrons into the orbitals. Okay, so this was the concept. Now, let's move to our higher topic because we have left with much time. Okay, Bachchi ji, is there something else we should talk about in this topic? So now, This was whole about the concept of, see, we have talked about our energies, but now the point is how would we feel our atom, or we can say electron, in these atomic orbitals. So this is our next concept. The topic is feeling of orbitals in atom. And just now we have completed energies of atomic orbital. Same as it is, we will see how the feeling of orbital is possible. It is also dependent on different rules and laws. Okay, and these different rules and laws were given by many different scientists. So to give them honor, we have provided the name on the basis of the name of scientist. Okay, so the very first basic rule is our Afbu principle. Afbu was a scientist who gave us a principle on the basis of which we can fill up our orbitals in an atom. Afbu told us that in the ground state of atom, orbitals are filled in the order of their increasing energy. Afbu told us that in the ground state, orbitals are filled with order of increasing energy. And how can we arrange them? We have just studied. We have just completed this topic. That is on the basis of n plus L, and on the basis of lower n, we have talked about that how can we easily differentiate our topic. Okay, so on the basis of n plus L value, what I can say, the order of increasing energy of orbitals are filled up. Okay, so this was the first rule which was given by the scientist of Polis Principle. Okay, now let's move to our second rule, that is Polis Exclusion Principle. See, till now what I have told you, you must have gathered the information that our filling of orbitals as well as the energies of atomic orbitals, these both are totally dependent upon different kind of rules. Okay, and each rule has something special to it which gives some information, and on the basis of that information we will keep on and we will get our final result. Okay, so this is not our final result, it is just an information so that we are building up how can we fill our orbitals in an atom. Okay, so let's start the Polis exclusion principle. Polis exclusion principle was very simple, quite obvious. He just told us that no two electrons can be filled in an orbital with same spin. What I'm talking, that no two electrons in an orbital can be filled with same spin. The point here is, I have told you in our quantum number ms that in ms there is -1/2 as well as +1/2. Okay, so there is a kind of, we can say, rotation of the electron in the positive state as well as in the negative state. So he told us that this concept is totally wrong. Same as it is, this concept is also totally wrong. We have just this observation. This is the only outcome on which we can focus. This is the only result on which we can say our electrons are filled. Okay, so this was the second rule which is given. Okay, so now we are left with just one or two more rules, and after that we will going to finish the topic. The last one is Hunt's rule of maximum multiplicity. But these all rules now very important, not only for the basis of electronic configuration, but also for exam point of view. You will get the question in 2 marks, explain Afbu principle. You will get explain Polis exclusion principle. but explain Hund's rule of maximum multiplicity with example. Within 2 to 3 marks, you have to define as well as with the examples, you need to explain them. Okay, so just keep that in your mind. The last one is Hund's rule of maximum multiplicity. So this is the last rule. Okay, now what Hund's rule have told us? He have told us that suppose if we are having 3 orbitals for P, 1 orbital for S, and 5 different orientation for D orbital. He told us that first the all orbitals must be filled. Only then we would start with our next electron. What I'm saying, he told us that each orbital, suppose this is Px, this is Py, this is Pz. This is what we have talked in our previous class, now that there are 3 different representations of P orbital. He told us that for each kind of orbital, every orbital must contain a single electron. Only then we would go with the second electron. So if these are completely half filled, only then we can jump to the next one. Okay, so this is not a case. This is totally wrong. This told us, this was given by Hund's rule. Same as it is, we can say that the 4th electron would enter in the first atomic orbital, because first we have to finish the 3 orbital, na? So 3 electron. Na? Same as it is, if I'm talking about D, he told us that 6th electron would enter, because first we have to fill the all 5 different atomic orbital by a single electron. Okay, bache? So this was the 3 different rules on the basis of which we will start our electronic configuration. Should I repeat it? The Hund's rule, which told us that each orbital must contain a single electron. Only after that we can go to our next level. Okay. If I'm talking about Polis exclusion principle, he just told us that no 2 electrons can be filled an orbital with the same speed. Okay. And lastly, Afbo, he told us that we have arranged them in the order of increasing energy, and we will start filling up the electrons. Okay. So this was the whole concept about the energies of atomic orbital as well as filling of the orbitals in an atom. So this was the whole concept which I wanted to deliver to you. Now, if there is any kind of doubt or query, I'm open to that. You may please ask to me. And I just want to say one more thing, that in tomorrow's class, what we need to go, what we have studied in our 2 topics, that is energy and shape of atomic orbitals. Okay, we would go with the outcomes. We would going to apply them to get the electronic configuration. So this is very important thing which we are going to study in our tomorrow's class, that on the basis of these all rules, we are going to apply them practically. Okay, so this is, we can say, a practical application of these rules to get our electronic configuration, which is very important. Okay, so this was all about by my side. If you have any doubt or query, please ask to me. Yes, students,